Okay, so next we go to the different design configurations. First, we have the so-called temporal or sequential. So the concept of a temporal design is that this one operates using a single detector. All right. So the single detector, wherein successive radiation bands are examined sequentially in time. Ito yung single beam design. No? Example, ito yung single beam design. So, paano yung single beam design? So, basically, you only have one cuvette compartment. Alright? So, paano ito ginagawa? No? So, first, you have to place the shutter. Yeah. Place the shutter and then invoke yung auto zero. Okay? Or zero instrument. So when you zero the instrument while the shutter is closed, you are canceling what you call the dark current. Now, in dark current, that is the reading in the detector in the absence of radiation. And this is due to the nature ng electronic circuit for the detector. After that step, you release the shutter. Alright, you place your reagent blank or your reference solution, okay, your solvent solution, kunwari, and then you zero again at 100% transmittance. So that step naman cancels out the reading from the reagent blank. Then after that step, that's when you now start measuring the absorbance of your sample. Okay? Now, um, the advantage of this design is that it's simpler, no? Yung mga meron pa rin naman ito ngayon, no? Pero yung mga sinaunang spectrophotometer, single beam talaga ang original design, no? Especially yung classic na Spectronic 20, no? Kung mag-google niyo yun, interesting yan, no? Sa history ng development ng spectrophotometry. Okay? Ang disadvantage is that yung light source mo, kung nagpa-fluctuate due to power fluctuations, okay, yung ginawa nating zeroing of the reagent blank or the reference solution becomes invalid. Okay? Because remember, transmittance depends on the intensity also or the power of the incident light. Okay, so if there are fluctuations in the light source due to power fluctuations, consequently, there will also be fluctuations in the intensity or power of the incident light. Okay, which will cause error. Error dun sa inyong analysis, alright? So, sorry. So for non-dispersive single beam instruments, again, when you say non-dispersive, you have filters. Alright? So you have to interchange filters depending on the wavelength you are interested. Okay? The disadvantage, of course, of using filters is that you would not be able to produce your spectra. Okay? But if you're using a dispersive element, okay, it means to say that you are equipped with a monochromator with a dispersing element that is rotated. So, with the monochromator, you would be able to obtain the spectra for your sample. Okay, so next you have your spatial design, and this is the principle behind a double beam optical instrument. So a spatial design is based on multiple detectors or channels to obtain information about different parts or elements of the spectrum simultaneously. Okay? So basically here, you it's either you have two detectors, no? Such as this one, yung case nito, or you have a beam chopper, no? So the beam chopper allows you to even though you have only one detector, okay, you can read yung reference cell, then afterwards the sample cell alternatingly. Okay? But if you have two photodetectors, no, which is, I think, mas madaling i-imagine, no? Okay? You can detect simultaneously, alright, the reading for the reference cell and the sample cell. Okay? And then you can cancel directly, no, the reading from the reagent blank, no, sa reference cell. So the advantage of a double beam design is that it compensates for any fluctuations, no, in the light source due to power fluctuations. No? So that's one advantage, no, of your double beam design, and this is the reason why most spectrophotometers nowadays include this type of design. Okay, if you're using a non-dispersive instrument, all right, you need to use multiple filter systems. So there are separate filters, no, for the reference and the sample cell. Okay, but if you're using a dispersive monochromator, no, this will contain monochromator plus a series of slits, all right, and a number of detectors. Okay, of course, na ito yung modern design, no, so this is more complex, mas mahal, more costly, but this is microprocessor controlled. Okay, so this enables you to get your spectra faster, and it has enhanced sensitivity and precision. So lastly, you have your multiplex design. So single channel devices in which all signals are observed simultaneously. So this is possible with the use of detectors such as photodiode array or charge-coupled devices, no, which are capable of recording simultaneously the data or the information from all wavelengths, no, coming from the instrument, from the sample. All right. So since you're able to collect the data simultaneously, multiplex design offers the following um, advantages. The first one is the so-called throughput or Jacquinot advantage, where in few optical elements you don't have any slits, walang exit slit, no, to attenuate radiation. Because remember na the presence of many optical elements such as mirrors, lenses, and then yung exit slit from the monochromator, it actually attenuates, no, or reduces the intensity of the radiation. And whenever it does that, it leads to lower uh, lower energy, or sorry, lower power of the radiation going to the detector, and this causes lower signal to noise ratio, no? Pero vice versa, if you have higher intensity of the radiation reaching the detector, this will lead to high signal to noise ratio. Okay, also this design offers high wavelength accuracy and precision, which makes signal averaging possible, no, and thus leading to signal to noise ratio. Please review yung different ways to improve signal to noise ratio, yung hardware based and software based, although they seldom appear in the board exam, no? It's important to note also, no? So signal to noise ratio is an important parameter in instrumentation. Okay, so it tells us how well the instrument is capable of um, differentiating, all right, between the analytical signal and the background noise, no? So it's very important. Then lastly, you have the so-called multiplex or Felget advantage, wherein all elements of the source reaches the detector simultaneously, and you are able to obtain the entire spectrum in a brief period of time. Okay, so examples of devices, or sorry, instruments that follows the multiplex design would be, of course, your ICP, inductively coupled plasma, okay, which uses a charge coupled device detector. Another example actually would be your FTIR spectrophotometer. No, the FTIR spectrophotometer technically, no, follows a multiplex design. Okay, what else? In HPLC, no, since this is a review already, no, if your HPLC unit is equipped with a photodiode array detector, then the detector, no, not the chromatogram, but the detector follows a simple multiplex design. Okay, so that's it for part 2 of module 8. So again, I will be uploading the self-assessment exam. Siguro I'll just put the answers, no, on every succeeding PDF file. Okay, sorry about the delay. Okay, so again, for any questions, uh, maybe you can post it in our FB group, or later we will make our Viber group, or what else? FB group chat. Yeah, okay, so thank you.